7.2b here at Advanced Algebra 2, first 4 problems are just a refresher of what our homework was about last time. You see where the variable x is located is in the exponent. Setting us up for logarithms next time. What we can do, which is much easier to do than use logarithms, is if we can rewrite the bases as the same number, then we could solve for the x really easy. Isn't this guy base 4, correct? And this is base 64. What could we rewrite them as? Can we rewrite base 64 and base 4 as the same base? What do you want to choose? Base 2 would work. What else would work? Base 4. So this is 4 to the 2x plus 6. And what is 64 rewritten as base 4? 4 to what power is 64? 4 to the what? Third. What's still there is the 2x minus 4, right? Here we've got a power to a power situation, so we got to clean that up a little bit. This is still 4 to the 2x plus 6, and that'll equal 4 to the, distribute that 3 through, right? Doesn't it have to get multiplied by that whole binomial right there? So that is, go for it, 6x minus 24. Now we're golden. Aren't they both base minus 12? My bad. Sorry. Thanks. 12. Good with that? Minus 12. Aren't they both base 4s now? Correct? Since they have the same base of 4, these exponents, for these to be equivalent, these exponents have to be the same thing, right? So we just drop the bases and we set the exponents equal to each other and solve for x. Please solve for x. Please solve for x for me. And we learned, if you did your homework, which I'm hoping that you did, that not all the times did x come out very nice. We're good with 9/2. What's the next thing we got to do? Check it, see if it works. So let's check. Squiggly. Let's put 9/2 in for x into the original equation. The beauty of that 9/2 is when you take 9/2 times 2 right there, what does the times 2 and the divide by 2 do to each other? So you really have 9 plus 6 right there. That will equal 64 to the 9 minus 4. Right, because the times 2 and the divide by 2 cancel each other out. Right? What's 9 plus 6? 4 to the 15th. 64 to the 5th. Now we go to the calculator and we punch them both in to see if they are equivalent or not. 4 to the what? 15th. Yowza! I don't care how large it is. We're writing that puppy down. 10, 7, 37, 41, 824. 10, 7, 37, 41, 824. Did I get that right? Dang, I'm good. Commas needed. 64 to the 5th. See if it's the same thing. Hot bananas. Good for us. 10, 7, 37. 41, 8, 24. I got my commas in the wrong place. Did I miss a number? I just have commas in the wrong place. Check. 9/2 was the solution to that puppy. Awesome. Next one, memory refresher. This is base 5. Ooh, that's a fraction. Who cares about that fraction? What's the trick to make that fraction flip over? Our base has to be negative. See if we can rewrite them both as base 5s. See if we can rewrite them both as base 5s. This one already is base 5. How do you turn a 625 into base 5? 5 to what power is 625? Oh, thank you, spring break, for making logarithms all that hard because we don't know our perfect note card anymore. 5 to the what? 4th is 625, but I want it to be flipped over, so what will we really have? 5 to the negative 4th. Now they're both base 5s. Solve for x. drop the base 5s. And let's check to see if that works. So I got 5 to the 3 minus. Boy, I like that times 2, and that's a 7/2 right there. What is that really? 2 times 7/2 is really 7, right? And it was the minus. I want to see if that equals 1 over 625. That's really 5 to the negative 4th. You never, ever punch in a negative exponent into your calculator. You use the negative exponent first. Isn't that really 1/5 to the 4th power? Right? You reciprocate the base. It's still to the 4th. And what's 1/5 to the 4th power, baby? 1 over 625 equals 1 over 625. Check. 7/2 is our solution. Yes, sir, Bob. Try 3. Pause the video. Get that done. Don't let the fraction scare you. It means we got a negative exponent to deal with. -7. Yeah. Una más. Can we write them as both base 25s? Like 25 is a smaller base. Can you write 25 as a power of 125? 25 to some power equal 125, yes or no? Nope. So what can we get for the same base? Rewrite them both as base 5s. That's really 5 squared. X minus shui. That would be 5 to the negative 3rd to the x plus deuce. This is really 5 to the 2x minus 6. 5 to the negative 3x minus 6, because you do a little distributing. (5x minus 6 equals negative 6). 5x equals 0. That's weird. X equals 0. Well, let's check to see if it works. That would be 25 to the negative 3rd equals 1/125th to the 2nd. Use that negative exponent. Right, so far? And then what do you punch in here? Refresh my memory. Like, I don't want to type in 1/25th cubed. That'll give me a nasty decimal. What are you typing in instead? 1 cubed, which you should know is 1. 25 cubed, which you probably don't know, but can't you punch that in, like 25 cubed? What is 25 cubed? 15,625 with a comma. That'd be sweet if that's what 1/25th squared would be. Is that what 125 squared would be? Check it. X is goose. Memory refresher. Feeling groovy about those. More of these on your homework today. Write an exponential function. Give yourself a little helper up here. Here's our parents guy. That's the parent for an exponential function. Y equals A times B to the X. Cool? Doesn't the normal graph of that thing look like this? Let's just pretend it's exponential growth, okay? What is the magic point on any exponential situation? Right here, 0, 1. Isn't that the y-intercept of that thing also, okay? It is like the initial starting value, if you will. Because if you put this into a story problem, which is what's coming up, is some story problems, is you'd have some unit of time here on your x-axis and some other label right here. You get rid of these quadrants because they never really matter in a story situation. And what does this x value stand for right here? What's x stand for? Time. And if time is 0, isn't that like when you started, right? We're not talking about the year 0. It just means, all right, initially there was this much. Cool? Well, do you see that out of the 2 points that they have given, the first point is always 0, comma something, right? This is our y-intercept. We will generically call that 0, comma a, right there. Please put that above this. The first point they give you, 0, whatever, that 4 right there, they're telling you that's your a value. Okay? That's your initial starting value. Initially, right, when x was 0, y turned out to be 4. Sound cool with that? This other point, it's just an x and a y point, x, y. The first point is your y-intercept, 0a. The second point is an x, comma y value. Awesome. Let's write our parent function down generically first every single time. Y equals a times b to the x. Is everyone cool with that? In this generic formula, watch me count them out. There are 1, 2, 3, 4 variables in it. There's a y, a, a b, and an x, correct? 1, 2, 3, 4 variables in it. We have 1, 2, 3 of them so far. Notice that's not a variable. That's the number 0, correct? Don't we have 3 of the 4 variables already? Which one don't we have? We don't have what the base is, right? We do not know the base. So here's the thing. They have basically told us that here's some points, and it's going to be an exponential graph. How do we know that? Because they tell us so. Write an exponential function. This is going to be an exponential situation, sir or ma'am. It's going to pass through these points. Well, here's where it started. Here's some other point on the graph. Let's take the parent function and substitute what we know. We know a y. It's how much? 36. Do we know an a value? It's 4. We do not know b, so it is still a b. And we do know that x is a 2, and that's up in the exponent. Is everyone down with that? Our job is to solve for b. It's being squared, and it's also being times 4. What do you need to get rid of first, the times 4 or the squaring? You get rid of the times 4. Anytime you solve, you do the order of operations backwards. You always do the order of operations backwards. Whatever you're solving for, you get rid of anything added or subtracted to it first. Then you get rid of anything multiplied or divided by it. Then you get rid of any exponents. Then you get rid of any grouping symbols. When you solve, you're doing the order of operations backwards. We need to get rid of what's being multiplied by that first. Get rid of the times 4. How do you get rid of the times 4? What's 36 divided by 4? 9 equals b squared. Is everyone down with that? Now, how do you get rid of that squared? And what does b equal? Is that all? 3, 4, negative 3. Algebraically, those are the two possibilities for your base. The base could be 3, or the base could be negative 3. That's the algebra. Exponential rules. Tell me about the base. What have you remembered so far? Thank you, spring break. Tell me about the base. How do you know if it's exponential growth? The base is more than 1, right? How do you know if it's exponential decay? Don't say less than 1. It's got to be between what? 0 and 1. So what does that mean cannot be the base? 0 can't be the base, and it can't be what kind of numbers also? Negative numbers. So even though these are the two algebraic solutions, boop, boop, that's an extraneous answer because the base cannot be negative in this situation. Awesome-o? So our job now is to rewrite our function with the information that we know. X and y, now they become just our generic variables. It will be y equals. Let's go off to the right a little bit. Y equals. Do you know what a was in this situation? 4? What's the base now, baby? We totally figured out what the base was. What's the base? It's 3 to the x power. This is the exponential function that should get us back these 2 points. Let's check the calculator to see if those points are actually on there. So let's go to our graphing calculator and let's type that in. Junk out. Okay, clear all that stuff out and type it in. It was 4 times 3 to the x power. Is that right? Going off memory here. Is that correct? Yep. Cool. You can graph that if you want to. I don't really care about graphing it. Don't we care about some ordered pairs in this situation? All right? Where's a great place on the graphing calculator to see a whole set of ordered pairs together? The table. So go to, make sure you have it typed in, and go to second table and see if those points are on there. Is the point 0, 4 on there? And then what was the other point? 236. Now my table, do you see how I've got my table set going all kinds of goofy? It's going by 2s. If yours is all messed up because we did that a while back, you go to your second table set, and then you can have your tables go by 1s instead, which is probably something we need to fix back. Correct. And then hit enter. And then second table. Now it's going by 1s again. But still, aren't those 2 points on there? One more thing I'd like us to put, because our homework asked it, exponential growth or exponential decay. What is this situation? Please spell exponential correct. Exponent, I-A-L. It's exponential what? Why is it growth? Base is more than 1. Feel good with that? That was an exponential growth situation. Now, let's try number 6. Again, I want you to put these 4 things above the points that they give us every single time. This is 0, comma a, and this is x, comma y. The first thing they give you, since it has a 0, that's your initial starting value. Initially, for whatever's going on, there was 2 of these things, right? If it was a bacteria problem, when they started, there was originally 2 bacteria, 0a. Then after 5 hours later, there was 486 bacteria. That's what the problems will end up saying, something like that. So start with your generic formula every single time. Y equals A times B to the x power. I want you to write it down every time. Substitute the 3 ingredients we know. We know A, we know X, and we know Y. Don't forget, they told us in the instructions it was an exponential situation. That's why we're starting with this formula. That's the generic exponential. So, 486. A is how much? 2. B, I don't know. 5, right? What's the next method? Divide by 2 or 5th root? Divide by 2. Isn't that 243? What's the 5th root of 243? Since that's to the 5th power, we 5th root. What's the 5th root of 243? Is it 3 or negative 3, though? It's just 3, right? When there's an odd power here, you only get 1 answer. When you have an even power, there are 2 answers, but we'll always throw away the negative. I want you to put the 2 answers, if there are 2 answers, and cross it out. So now we found the base. Let's rewrite our actual exponential equation and box it. Y equals A, which was what? 2 times our base of 3 to the x power. This is exponential what? Growth, because the base is more than 1. Then you could double check, put it in your calculator. If you really wanted to, you could just substitute these numbers in. You could say 2 times 3 to the 5th and see if you get 486. You could take 2 times 3 to the 2nd and see if you get 0. Or sorry, 2 times 3 to the 0th and see if you get 2. Right? You can substitute them in. You can punch the whole thing in your graphing calculator and check it to see if it works. All cool with that? Let's roll to the next one. Let's do it again. Start it off. 0a xy. Generic formula. They told us it's exponential. That's why we're starting with this. Substitute in. have an odd power and you take an odd root, you'll only get one answer back. So the base is 2. And that's an exponential growth. And you can double check. It was what? 3 to the 2x? 3 times 2 to the x, if I say it right. Yeah, those points should be on there. 0, 3 for sure. What was the other one? 324. It is on there. Go Ruby. Last one, I think, before they get interesting. Let's try the Ocho. Pause the video, get it done for me. I hope we've gotten this far, right? And we did do some bank problems before spring break, you know, where they were exponential growth, and weren't the growth factors like 1.03 and 1.055 and stuff like that? Is every base got to be an integer? So what do we got to do to solve for b here? If that's b to the 4th, what do we got to do? How do you get rid of the 4th power? 4th root both sides. Cool? So b will equal the 4th root of 27. Will there be 2 answers? Plus or minus the 4th root of 27. Everyone cool with that? Well, both answers make sense. Can't have a negative base. How do you punch the 4th root of 27 in your calculator, just out of curiosity? How do you actually do that? 20 to the, like 1 divided by 4? In parentheses, 1 divided by 4. So, nasty, right? Nasty, but look at the base right there. More than 1 or less than 1, more than 1 or less than 1, more than 1 or less than 1. Isn't that more than 1 right there? But I don't want to write that nasty number down. Some people will tell you to round that to 3 decimal places. I'm a dude that does things exact. Cool? I'm going to leave this, my base, to be the 4th root of 27. Awesome? I'm not a big fan of this. Some people will say, well, let's write this now. Now that our base is this, we'll say y equals a is 3 times the 4th root of 27 to the x. I'm not a real big fan of that either. Instead of having a radical with it, to having a rational exponent, yes or no? Instead of the 4th root of 27, I mean, you just told me what it was right here. What is it really? 27 to the 1/4? So I really like this instead. It's 27 to the 1/4. Please write that down for your example. But I am still not done with that. What can be cleaned up even further than that? If I told you that you had something like this, could you clean that up a little bit further? What's x squared to the 3rd? X to the, because it's a power to another power, 27 to the 1/4 to the x. What should you do with those exponents? Should you add them or multiply them together? Multiply them together. So how about y equals 3 to the, 3 times 27 to the, what's x times 1/4? How about one number instead of 1/4 x? X over 1 times 1 over 4 is really what? X over 4. Exponent right there. 1/4 times x. Since x is in the numerator, you take numerator times numerator and denominator times denominator and get x over 4. Isn't that nice and clean now that you've got that? Here's what I want you to do, though. Let's punch that in our graphing calculator and see if we get our 2 points back. Because even though I like that version, that is very difficult for people to punch into their graphing calculator. It's 3 times 27 to the x over 4 power. So clear this out. 3 times 27 to the, come on baby, tell me what to type next. I need a parentheses because isn't the exponent a fraction, correct? So it is x over 4 in parentheses. Y'all good with that? Now let's check our table. 0, 3, wasn't that one of the points on there? And 481, was that the other one? There they are. Exponential growth or exponential decay? Exponential what? Growth. Exponential growth. Next. Let's see how we do on the nueve. Set it up. Let's see if it comes out nice or not so nice. I got it this far. Formula subbed in 0axy. What's my next move? Divide by 9. That doesn't come out nice at all. It's really not that bad though, because that's what b squared equals. And I really actually like the number 49 and I like the number 9 because they're what? Perfect squares. Now we need the square root next, right? So b equals 7/3, or why are there two answers? Because this is what kind of exponent? Even. Throw out the negative guy, can't have him. My base is 7/3. So I got y equals a, which is how much? Base of 7/3 to the x power. Groovy? Exponential growth or exponential decay? Exponential growth. Because that base is more than 1. Last one, without a story involved. Why don't you pause the video and get her set up pretty far for me. Probably going to come out nasty. Hopefully you got her down to here. Got a 4th root 12. Is 12 a perfect 4th? Not at all. So we'll have a plus or minus situation, negative 4th root of 12 or positive 4th root of 12. Don't forget your little index. That equals b. Since the base can't be negative, it seems like, why are we writing that down? Just to practice good algebra skills is why we're writing that down, because you always get two answers when you solve a even power. So now I will rethink of this as 12 to the 1/4 instead of the 4th root of 12. Is that cool with you? Now substitute that back in. Give me a nice, neat, clean, and concise answer. A is 12. The base I will have is 12 to the x over 4th power. Isn't it 12 to the 1/4 to the x, which is really x over 4? The question is, what is that base really? It's the 4th root of 12. Is it more than 1 or less than 1? So 12 to the 1/4. Let's see if that's more than 1 or less than 1. That's a more than 1, right? Exponential growth or exponential decay? No, they won't always be growth. Cool. There are some exponential decays on your homework. They're not all going to be exponential growths. Okay? This is the initial value, because what is the x value right here? 0. That's how much you started with. So, aha! Story! Kristen starts an experiment with 7,500 bacteria cells. After 4 hours, there are 23,000 cells. If you sketch a rough graph, there are 2 labels that you'd have on here. Bacteria cells, take a wild guess what's on the x-axis. Hours. Isn't hours the other thing? hours right here and number of cells right here. Isn't X hours and Y is cells, correct? Starts, how many hours went by when she started? 0. So let's write 2 ordered pairs right here. 0. How many bacteria did she have, though? 7,500. Let's slow down a second. If X is hours and Y is cells, which they actually kind of tell you that in this part A, after 0 hours, she had 7,500 bacteria cells. Doesn't that make perfect sense for that? Right? I need another ordered pair. And it better go hours, cells. What do you want to do? 4 hours, 23,000 cells. Again, they kind of tell us it's exponential, right? Without that information, it's like, how do you know it's exponential? With that information, we really wouldn't. They have to kind of tell us that. So let's do the same thing we just did now. Now it's 0a x y, right? Same story. Y equals ab to the x, 23,7,500 b to the 4th. 23,000 divided by 7,500, is that what we're doing? I'd like to keep that a fraction, please. How could I turn that into a fraction very easily after punching that in my calculator? Math enter. There it is, 46/15. Cool. So 46/15, maybe, if my pen would work, equals b to the 4th. Ruby? Now what do you do? 4th root, so b equals the 4th root of 46/15, or the negative version of it. Throw out the negative. I still like to use the radical in that situation. It's really not that big of a deal if you want to use the rational exponent of to the 1/4. But I use that just to see, it's like, you know, it would be cool if 46 was a perfect 4th and 15 was a perfect 4th. Are those perfect 4ths? So I'm done there, right? I'm not going to simplify that any further. I just need to now write my actual equation. My y will equal the a value. How much did we start with? 7,500. My base, I'm just going to keep it as 46/15. And it's really to the 1/4 to the x, correct? So what is that really to? To the x over 4 power. Maybe. Fabulous? This is the exponential situation. Is it growth or decay? It's pretty stinking obvious that it's growth, because what happened from here to here? Did it grow or did it decay? It grew, right? And if you said growed, way to go. It growed, grew. Now, do part B. How many bacteria cells can be expected in the sample after 12 hours? What is 12? Is it an x value or a y value? It's hours, right? Isn't that an x value? So I'm going straight to my calculator. First, why don't you write down what you're going to punch in for me. 7,500 times 46/15 to the, don't you put 12 in for x right there? But it's got to get divided by 4. So since that comes out real nice, what do you got? Now let's see if you can punch it in correctly. 7,500 times 46/15, is that the right number? 46/15 to the what power? 3rd. And then we'll round how they tell us to round. This is like how many bacteria cells, so it's about, it's approximate, all that kind of stuff. What do you want to round to? 10th, whole number, 100th? What makes more sense to you? Whole number, right? About how many cells? 216,302. So y is about 216,302. What? Cells. Fabulous. All right. That's exponential equations given some starting values. There's more story problems on your homework, but hey, starting value, some other point. All right? Starting value, some other point is what it's all about. This should interest you. That's funny. No pun intended. Compound interest. It should interest you. Right? Compound interest. When you put money in the bank kind of stuff. I hope you like money because money is what drives this world, unfortunately. Compound interest. Compounded means how many times a year does it earn interest. If you have a savings account right now, I guarantee you, you don't have a savings account that only earns interest one time a year. It's not like you put money in on the 1st of January and it sits there 365 days until it earns interest. Most banks give you monthly interest. Like every month, you'll make a little bit of money off of it. Sometimes banks give you more interest than that. They might give it to you compounded quarterly. That's actually less. But what does quarterly mean? Quarter. 4 times a year. So that's every 3 months, which is less than monthly. Sometimes they'll give it to you weekly, right? Sometimes they'll give it to you daily. And sometimes there are certain accounts that give it to you continuously, which you'd be lucky to find one like that, but continuously. Every single instant of the day, you earn interest. We'll learn about continuous stuff when we start studying our number E. But, did you say number E? Yes, I did say number E. Compound interest, right here. First, let's figure out this. How many compounding periods? If you compound something annually, how many times a year does it get compounded if they say annually? 1 time a year. Right? Annually just means they got 1 compounding. They put the interest on you once. Semi-annually, what do you think? 2 times a year, right? 2 times a year, semi-annually. Every 6 months, you earned interest in that situation. Quarterly, we've already discussed, is how many times a year? 4. Monthly is 12. Weekly, how many weeks in a year? 52. Bi-weekly. It doesn't mean twice a week. It means every 2 weeks, right? Bi means every 2, so what would you do? 26. Bi means every 2, right? So every 2 weeks. If we say bi-monthly, every 2 months, that would mean you did it how many times a year? 6. And for daily, we'll use the rounded number of 365, even though there's really 365 and 1/4 day in a year. That's why after every 4 years, you have to add a day, because there's really 365 and 1/4 days. And every 4 years, that 1/4 plus that 1/4 plus that 1/4 plus that 1, that's called leap year. Magical. So, compound interest. I guess we got to go through this formula. A means what's the amount? How much will you have in the bank? P stands for the principal. That's how much you originally invested, right? So you put money in, it's called your principal right there. 1 is 1, R is your rate as a decimal, N is the number of times compounded, N is the number of times compounded, and T is the time in years. Cool? So let me write that up here again. Whoa, psycho. Let's try that again. A equals P times 1 plus R over N to the N times T power. You're going to need to get that formula memorized. Okay? Let's go to the next page where we got some problems like that. Write it up at the top. It really looks kind of complicated if you understand the order of operations. It's very, very simple. The first thing we'll do is substitute in everything we know into this formula. We should know all the ingredients but one. So let's read this. An investment account pays 4.2% annual interest compounded monthly. If $2,500 is invested in the account, what will the balance be in 15 years? The most obvious thing in there is this. There's our rate. We don't want it as a percent. We want it as a decimal. What do you got? So I like to write that above that, 0.042. Okay? Do we know how much we started with? So do you realize that we know the principle, right? Eventually it'll get to the point where we'll know the amount and we don't know how much we started with, right? But for right now, we know how much we started with, know the rate. How many times are they compounding this thing? Do we know? Do we know the number of times this was compounded? Yeah, monthly. I want a number. What do you got? 12 times. And do we know the time involved? 15 years. What we don't know is what the amount will be in our investment over that time. So we don't know A. Let's start with A equals. What's our principal? $2,500 times the quantity of 1 plus our rate as a decimal, which is 0.042, over the number of times compounded. What was the number of times compounded? 12 raised to the number of times compounded, which was what? Times the number of years, which is 15. Is everyone good with substituting the information in? We will clean one thing up before we punch this in the calculator. We will clean this up right there. 12 times 15. What is 12 times 15? I have done this hundreds of times with students, and I feel that you should write this, then lightly cross it out so I can read underneath there. And please tell me what that was again. What's 12 times 15? 180? 180. Cool? So please write it so you make sure you understand where it came from. Cross it out, punch it in, put it right there. Now let's follow the order of operations, my friends. Grouping symbols. We have them, correct? We need to do what's inside the grouping symbols first. Isn't there some adding? Isn't there some dividing, correct? What needs to happen first? See, if you try to punch this in from left to right, you're going to have some serious knowledge of parentheses, of how to type this in correctly. I'm trying to help you. Let's just start inside the parentheses. Adding or division, what comes first? Grouping symbols, we're in them. What do you need to do first? Adding or division, what comes first? Doesn't division come before addition according to the order of operations, right? So let's punch this into our calculator right there. We need to figure out what 0.042 divided by 12 is. Isn't it that? What that means, just since we've done this before, hopefully, is you don't earn 4.2% interest over the month. You earn 4.2% interest over the entire year. But since they're dividing it 12 equal ways, don't you earn 0.35% interest that particular month, right? That month is what you earned. So we have done this. Never clear these numbers out of your calculator. Would you all be good that we have done this, right? What is next that needs to be typed into our calculator? We need to add 1 to it, so plus 1. And do you see how our money should grow? Because isn't this number more than 1? This is the base right here, correct? So now we have this complete. There are two things left to do. Take whatever that number is, times 2,500, or raise it to the 180th power. To be done first, according to the order of operations, the exponent or the multiplication. The exponent. We need to take this number and raise it to the 180th power. Didn't our money get compounded 180 total times over that 15 years? Because it was 12 times a year for 15 years, so it happened 180 times. So over all of that spiel, we just earned that as a base. Cool? Now let's take it times 2,500. Oops, my bad. And our money should be that. That should make sense. The interest rate was not that large. It was only 4-something%. We started with $2,500, and over 15 years, we now have $4,600 plus. Cool? How do you round money? 2 decimal places. So would it be 4688.86 or 0.87? And that is exact. You don't say you have approximately that much in the bank. That's how much you have in the bank. It's 4688 point what? 0.87. Label, please. Dollars. Cool. The higher the interest rate, the more this should grow. Cool. $2,500 after 15 years with 4.2% interest compounded monthly gives you that. That's pretty reasonable. It should not be in the millions of dollars. You made a typo if you started with 2,500 and now 15 years later you got $1 million. If that was the case, we'd all be billionaires by now. You know, here you go. Put $300 in the bank when you're born. By the time you're 18, you now have $1 trillion. Way to go. Next. Set it up for me. Compound interest. That's the question. Is it compound interest? Yes or no? Very simple. See this word? Compounded. And see that word? Interest. It's compound interest. So, what we won't know in these problems is the amount that we'll have. Do we know the principal? How much? $100. 1 plus my rate as a decimal. What's the rate? Well, not as a decimal, just what's the rate as a percent? 1.2%. What do you think about that? Good, bad, or you don't know? 1.2% interest rate. You think that's good, bad, or I don't know? It's okay if you don't know. You know, you're not the most experienced. What do you think? Good, bad, I don't know. That's horrible freaking interest rate. Anything under 4, like for you to make interest on, it's horrible, right? Anything 4 or bigger, that's pretty normal. If you get into double digits, you are striking it rich, baby. This is a savings account, right? Savings account is like the weakest thing you could do with your money. It's like, here, just put it in a savings account and let it sit there. You get measly little interest, right? Because there's no risk involved with the savings account. You're not investing it into anything. So, 0.012, is that right? Over bi-monthly, how many times is that then? 6 to the 6 times, how many years are we doing it? 20. Then cross that out. 6 times 20 is 120. Take a prediction before you punch this in. You got a really crappy interest rate, 1%. You left it in there for 20 years. You put $100 in. How much do you think you're going to get back after 20 years? Take a guess. Just you take a guess, and let's see what it actually is. 1%. What is 1% of 100? What's 1% of $100? $1. Right? So after 20 years, probably somewhere in the $20 range is what you should make. Pretty weak, right? Let's see. What are we punching in? This first. 0.012 divided by 6. Really, really small, right? What do you got to do to that? Add 1. Cool. It is going to grow, right? Isn't that number more than 1? It ain't much more than 1, though. Then raise it to the 120th power, right? Hey, times 100. $127.09. Yes. Like what happens is after the first month, you'll now have like $100.04 or something like that. Then the next month later, you take that $100.04 and add interest to that. So interest on interest on interest on interest. That's why compounding more often is more advantageous, because it just keeps giving you a larger number to compound it on every single time. Okay, one more. I think, right? Get her done. What do you think about your interest rate? Good, bad, normal? This is a normal interest rate. Anything 4 to 7 is a normal interest rate. Above 7, that's good. Above 10, that's fantastic. Why do you think credit cards charge you 23% interest? They are taking some serious money away from 23% every month. Really, that ain't too shabby at all. Like I said, that's a good interest rate. Think about a free way to make $2,400. You know, when you're 10 years old, somebody puts $4,000 in there. 8 years later, they just made you $2,400. You know, so now you have this much money to spend on college, which will get you a nice semester or two. You know, so but it's just free money. $4,000. You let the bank take its time.